So I already identified, but we have to see what are the allowed structure, right? There are two
Amino
types of
acids
structures.
that are present in the allowed
Ha,
region.
ha. Because some structure are totally not allowed. So rather than going for a lot of experimental work, laborious work, very simple graphical presentation is there by which you can predict which structure is allowed, which structure is not allowed, right? Because protein structure is made up of various kind of amino acids. So amino acids are going to adopt various type of structure like primary structure, secondary structure. You can see here. These are the amino acid sequences are going to form the primary structure, and then primary structure is going to interact in the same chain. Then this is called as the secondary structure, and they are going to form either sheets or helices. And when more than two secondary structure are going to interact, then they are going to form the tertiary structure. Okay, so this is the beauty of this part. And then when tertiary, more than one tertiary structure is going to interact, they are going to form the quaternary structure, right? So that is the beauty of this structure. But Ramachandran plot is applicable for what? Primary structure, secondary structure, tertiary or quaternary structure. That is the basic. Ramachandran plot is valid for secondary structure. Okay, because from the graphical point you will be able to know this alpha. There are two type of angle that is formed in the peptide bond. And what is the two name that is called as the CC alpha, that is phi, and C alpha and psi. So basically Ramachandran plot is prediction of the secondary structure basically, right? They are basically polypeptide secondary structure, not polypeptide exactly, for secondary structure. Which secondary structure must be stable because of the planar peptide bond, and which one should not be stable. So now you can see here, right? You can see here, this is the CONH, right? CO, red one is the O, CONH, that is the peptide bond, and this one peptide bond is going to link with the other carbon, right? Because other carbon peptide bond. So C alpha, that is the one kind of interaction, right? Where rotation is possible. R and H is going to rotate. Another is C alpha N, right? So if this one is fixed, one chain is fixed, other can move. Other chain is fixed, one can move. Both simultaneously cannot move. So the Ramachandran observed that these rotation are predictable, okay, and their angle can decide their stability of the bond, stability of the polypeptide chain. So this is the fully extended polypeptide chain, and you can see the arrangement of chain based on the interaction, peptide bond formation, right? That is the important. So they observe this geometry, they understand this geometry, and then they find that some may be cis configuration, some may be trans configuration, right? And we'll see here, this is totally the planar structure, right? Because almost 40% secondary structure, double bond structure is there, right? And resonance structure is there. So they predicted basically the rotation. So if C alpha N, this C alpha C, they can oxygen can rotate, right? And here Cn, they can rotate, and if they are rotating, this part is going to rotate. So that's the rotation was plotted, the rotation was plotted, and it was found that there are some allowed structure, and this angle was designated as a phi and psi. So which one is the phi? First tell me. Phi bond is?
The bond between the carbon alpha and the nitrogen.
Carbon alpha, nitrogen is called as the phi, and carbon alpha and carbon is psi. C alpha C psi, easily you can remember C alpha C psi and C alpha phi, right? C alpha psi and C alpha phi. This should not be confused, because now this is called as the torsion angle, right? This is called as the torsion angle, and there may be two directions. One is the clockwise, that is positive, and anti-clockwise is negative. Okay, so one movement is clockwise, that is positive, and other angle is negative. So you can see minus and plus designation is there only to denote it's a plus clockwise, minus anti-clockwise. Okay, so actually the Ramachandran plot is going to predict which movement is showing interfering, steric interference, right, and which one is permissible. So permissible angle they are going to predict between the two adjacent rigid peptide units which are moving to respect to each other, right? So you can see this animation, beautiful animation, and you can see also the bond between phi and psi. So this is 045, this is 090, 0180, right, 00. So this is called as the psi rotation. Only one time one can move, not other. Okay, so that is the beautiful part. And now you can see here the biophysicist Ramachandran. He was not at that time he was not in India. That's why he was influenced very much by the studies going on around the scientists, because our Indian scientists are basically totally political motivated. They are either belong to this party or that party. So scientists don't belong to any party, they only belong to peptide bond. So if you are belong to peptide bond, then you can visualize how the movement is going on. For example, I can show you here. Now see the graph very carefully. This is the Ramachandran plot, and this is the square, right? So starting from 180, 0, and then minus 180. Okay, minus 180, 0, 180, right? So this region is minus 80 to 0, minus 5, clear? And y position is psi. So starting here also with the minus 80, minus 180, 0 is minus psi. So minus psi, minus phi. This is belong to minus 180, minus 40 region, right? And then you can see this is the 90. Minus psi means 90. So this is the right-handed alpha helix. And white region is nothing, right? Means no structure is possible in this region. While a red region allowed, a red zone, you can see this is the allowed region, and yellow region is possible region. Okay, but allowed region is only denoted by the red region. For example, you can see minus 90 and minus 90.